Okay, because this will be 0. Maybe you could find the initial velocity in the y and then come back to this one. However you want to do it, but that's my hint for that one. Okay, so take a look at it. I think I told you earlier there's always like there's always going to be a hardest question that we've done so far in the semester. It's probably this one. So take a look at it, have some fun with it. Maybe don't do it tonight, sleep on it, dream about it, and then you'll wake up with the answer. If not, send me a message and we can work on it. Okay? All right, let's look at a couple more and then leave the last bit for any questions you might have. Oops. Let's see. Oops. Caught myself on that one. Good. The Apollo 14 mission to the moon, astronaut Alan Shepard hit a golf ball with a club improvised from a tool. The free fall acceleration of the moon is 1/6. So 9.8 divided by 6, I actually think I had that number wrong. Suppose he hit the ball with a speed of 23 at an angle of 36. How long is the ball in flight? And how far did it travel? Okay, so again, you might have slightly different numbers than this, but we'll do the problem with my numbers. Okay, so the acceleration in the y direction, negative 9.8 meters per second squared divided by 6. So you'll have to figure out what that is. We know the overall velocity is 23. And then we know the angle is 36 degrees. Again, be careful because you probably have different numbers. So it looks something like this. There's the overall velocity, there's the angle. And we want to figure out how long is it in the air, and then finally, how far did it travel? So in other words, what is the range? And then what's the moon distance minus the Earth distance? So you have to figure out how far you travel on the Earth. So this is a great question to use the range equation for. So for part C, you'll have to figure out the distance on the moon, subtract the distance from the Earth. Okay. Range on the moon minus the range on the Earth. So this problem, it's actually easier to do part B first. We'll figure out the range. It's easier because we could just use the range equation. We know the overall velocity. Don't forget to square it. Sine of whatever angle you have. And then divided by, I put the negative sign in for the magnitude. When we came up with the formula, the negative side went away. So, what's that? Sorry. Oh, yeah, sine of 2 theta, yes. Oh, thank you, Rick. I don't know what I was doing there. Huh. So, so the value that we have to put here is 9.8 divided by 6. It's like 1.67 or something like that. 6.3, good. Okay, so you'll have to use this here. And really, you have everything to do it there. Just make sure you put your own numbers in. And this is delta x. The range and delta x are the same thing. So that's doing part B first. And then we can go back to part A. So for part A, we could use the x direction. So part A, if you remember, it's figure out how long it's in the air. So take the x velocity. That's the range that you just found divided by the time. So then the time, doing a little bit of algebra, the range divided by the x velocity is 23 the x velocity. I think people are saying, no, you're skeptical of it, which is good. It's not. The x velocity is the overall velocity times the cosine of theta. This part is the x velocity. Okay, so you can get the time, take the range that you got from part B, divided by the x velocity. Not the overall velocity. The overall velocity is at some angle here. The x velocity is this part. Okay? And then finally part C is figure out take the range that you get from the moon, figure out what the range would be on the Earth, and subtract those from each other. Okay? Good. Questions on that one? Okay, one of the longest recorded passes in an NFL game was 77 yards. Oh, thank you. Was 77 yards. Okay, yards, perfectly good, but we're going to have to convert that into meters. Assuming that the pass was thrown at the optimal 45 degrees, remember that's where you get the biggest range, what was the speed at which the ball left the quarterback's hand? And we want the answer in meters per second. Okay, so longest pass, 77 yards. You might have a different number. You're going to have to convert this to meters. And left. Okay, so take the 77 yards, look up the conversion factor. How many meters is this equal to? So do that. So that's the range. That's what they're really telling you in this problem. The range is 77 yards, a certain amount of meters, pretty close to 77, but not exactly the same. And assume that theta is 45 degrees. How much is the initial velocity? So this problem is perfect for the range equation. Overall velocity squared sine of 2 times 45, and then divided by 9.8. So 2 times 45 is 90, so it would be the sine of 90, which is 1. So remember, this whole thing here is equal to 1. And then the only thing you don't know is the initial velocity. So range, make sure it's in meters, times 9.8. So I multiplied both sides by 9.8. Take the square root of that. That'll give you the initial velocity then. Okay? Good. Probably wasn't a Bears quarterback. Just kidding. I'm a Bears fan, but you know. All right, good. Yeah, it just dawned on me, like, I know me and Rick were alive when the Bears won the Super Bowl, but probably nobody else was. It actually happened. Okay. Even then, the quarterback couldn't throw 77 yards. Jim McMahon. All right, any questions on this one? All right. Any questions on anything? That's all really the new stuff I had for you today. Good, so I think I gave you a lot of information, a lot of stuff to work on. So don't hesitate to contact me. We can set up a Zoom meeting, however you want to do it, and work on whatever you want to. That's probably the easiest way. Okay, any comments, questions? So hopefully there'll be sound for the whole video today. That's our intention. And as soon as it's up there, I'll post it in case you missed something in class. All right, well, have a good night, and then Group B, I'll see you tomorrow. Group A, I'll see everybody in person on Wednesday, if not sooner through Zoom. Okay. All right, excellent.